Good morning, afternoon, or evening, cats and dogs. My goodness, already getting started with struggling through that grading. We've got the operations on fractions guided notes again, so make sure you have those out in front of you. And we're going to be working on numbers 29 through 41 in that set of guided notes, which is going to include adding and subtracting mixed numbers that have the same denominator, but also introducing you again or reviewing the least common denominator, something that you're going to need to be able to find once you start adding and subtracting fractions that have different denominators. If you remember, when you multiplied and divided mixed numbers, you had to make mixed numbers into improper fractions. If you are adding and subtracting mixed numbers, though, you don't have to. You can, although I think the work is quite a bit more difficult or more challenging if you do that. Some students will use that method. They'll change mixed numbers to improper fractions when they know that they're going to need to borrow to subtract fractions because they forget how to do it or they don't understand how to do it. So it's pretty smart to do that, and it is a way you can get around having to borrow. But in most cases, it's going to be easier to just leave them as mixed numbers. I do want to remind you as well that we do need common denominators when we're adding and subtracting fractions, but we don't need common denominators when we multiply and divide. So please remember that. There's lots of rules here, but these are things that I know you've talked about before. We just need to reinforce them a bit this year. You will remember also that there are guided examples typed throughout. I'm not going to go through those because these videos are already lengthy enough, but I am going to go through the examples that need to be completed by you. If you're ever struggling, though, look back at these examples or, of course, reach out for help as well. So in number 29, we have 7 and 8 ninths minus 1 and 2 ninths. Subtract your whole numbers. 7 minus 1 is 6. I had to type that guy in there because I realized I had a 7 first. My goodness, cannot subtract. Or I just forgot to subtract those numbers. And then we've got to take 8 minus 2, subtract our numerators. That gets us 6 as well. Keep the denominator the same. We get 6 and 6 ninths. But something you can't forget is you have to write your answers in simplest form. 6 ninths is not in simplest form. Divide top and bottom by 3 and you get 6 and 2/3 for your final solution. So you can see I made a little typo there that I had to fix without having to retype in those notes on a different document and copy them over. So it should be 6 and 2/3. All right, number 30. This one is an addition of mixed numbers problem. So we're going to add 5 and 3. That's going to get us 8. And then 6 plus 5 is going to get us 11. So we have 8 and 11 sevenths, but we cannot leave a mixed number and an improper fraction all together in the same answer. 11 sevenths is 1 and 4 sevenths. So add that 1 and 4 sevenths onto the 8, and our final solution will be 9 and 4 sevenths. All right, let's move on to some questions that involve borrowing. So this is what I was talking about, that I will sometimes see students who make mixed numbers, improper fractions to do these. That way they can avoid having to borrow. And again, that's not a bad strategy, but it will make your work a little bit more challenging. Because you can see here, we've got some pretty big whole numbers in front, and you end up with some pretty big numerators that you're going to have to then subtract. It's not a big deal, but it does require more work. So in 12 and 2/5 minus 4 and 4/5, I cannot take 4 from 2, and I can't take 4/5 from 2/5. So I do have to borrow. What does that mean? Well, I take 1 from the 12, so the 12 becomes an 11. But I don't just add like 1 onto the 2 and make it a 3. I'm adding one whole in the form of 5/5 onto 2/5. And I believe that's even shown in these examples. Yeah, it's stated up here. I just didn't actually write it down below in my work. But you're adding 5/5 onto 2/5, which gets you 7/5. Now, if you don't remember that, a trick you can use is just to add 5 to 2 and replace your numerator with 7, since 5 plus 2 is 7. Now subtract them. So take 11 minus 4 gets us 7. 7 minus 4 gets us 3. So our final solution is 7 and 3/5. Now, sometimes we're going to have problems like in number 32 where we have a whole number minus a mixed number. Very often, I see students give me an answer for this of 8 and 5/7. They're like, oh, 12 minus 4 is 8. Let me just tack on the 5/7. But that's like taking 5/7 away from nothing, and you can't do that. So you do have to borrow for this one. So 12 we can rewrite as 11 and 7 sevenths, right? Because 7 sevenths is one whole, and one whole plus 11 is 12. So if I rewrite it as 11 and 7 sevenths, take off 4 and 5 sevenths, 11 minus 4 is 7, 7 minus 5 is 2. We get 7 and 2 sevenths for our solution. So be really careful there. You could take 12 minus 4, which is 8, but then you have to take 5 sevenths off of that, which is going to leave you with your 7 and 2 sevenths. All right, so number 33 is probably something you haven't seen in years past, where you're taking a bigger whole number from a smaller fraction. So 3 and 3/4 minus 7. What I did was I just flipped this around and did 7 minus 3 and 3/4. But then I'm going to have to borrow. So I'm going to rewrite 7 as 6 and 4/4. So I'm going to take 6 and 4/4 minus 3 and 3/4, which will get us 3 and 1/4. But because I was taking 7 away from 3 and 3/4, this solution should be negative. So I basically just switched the order around, took bigger minus smaller, which we should do, and then realized that since I was taking a bigger number from a smaller number, my final answer needed to be negative. Keep in mind that I can't just do 3 minus 7 and get -4 and then just tack on the 3/4. That's not going to cut it here. So be careful with these. You will get a chance. There will be, as there was for multiplying and dividing, an extra practice sheet on adding and subtracting fractions as well. And of course, we'll give you an opportunity in class to ask questions if you're struggling with any of these things also. All right, so let's do some adding and subtracting with mixed numbers, but includes negatives. So again, you're going to see some typed up examples here where there are some negatives. We're subtracting with negatives. We need to see this as well since this is a pre-algebra class and it is an advanced course. So let's look at number 34. We've got -6 and 5/11 plus 2 and 9/11. Since the signs are different, I need to subtract these. So I'm going to be taking 6 and 5/11 minus 2 and 9/11. But because I can't take 9/11 from 5/11, I am going to borrow. The 6 becomes a 5, and this 5 becomes a 16. Why? Well, I added 11 11/11 onto 5/11, which is 16/11. Or I could do 11 plus 5 and just replace this numerator with 16. Now we subtract. 5 minus 2 is 3. 16 minus 9 is 7. So we get 3 and 7/11, but 6 and 5/11 was bigger and it was negative. So my final solution should be -3 and 7/11. Number 35, I started by adding the opposite and rewrote this, not there, rewrote this as -6 and 5/8 plus 4 and 7/8. Now, since the signs are different, I'm going to find the difference. And those rules only apply if it's an addition problem, which is why I added the opposite. So I'm going to take 6 and 5/8 minus 4 and 7/8, but I once again have to borrow. I wanted to put a lot of these in the guided notes since it's something that students forget how to do. The 6 becomes a 5. This 5, the numerator, becomes a 13. Add 8/8 onto 5/8. Now we subtract. 5 minus 4 is 1. 13 minus 7 is 6. So we get 1 and 6/8, which reduces to 1 and 3/4. And because 6 and 5/8 was bigger and negative, my final solution will be negative. All right, moving right along. I want to talk about the last thing here. And again, you will have some extra practice to try on this. I want to talk about the least common denominator because in the next video, you're going to be adding and subtracting fractions that have different denominators. So the least common denominator, or LCD, is the least common multiple, or LCM, of the denominators. So I just want to show you a couple of different options for finding the least common multiple. So I did type in some examples for you. The least common multiple, or LCM, is the smallest non-zero number that is a multiple of two or more numbers, which is different than factors. So you got to recognize those differences there. Multiples are going to be equal to your largest number, or they're going to be bigger than that number. So if I want to find the least common multiple of 6 and 8, one option I have is to list some of the multiples of 6, some of the multiples of 8. They go on infinitely, so I can't list them all like I can with factors. Factors, we have a finite number of those. But as I list them, I can ignore the zero, which is a multiple of everything. And the smallest number or the least number that is a multiple of both 6 and 8 is 24. And you shouldn't really have to show work to do it. You shouldn't have to list the multiples out. Now, in the second example, you're trying to find the least common multiple of 10 and 14. So the multiples of 10 are really easy to list, but the multiples of 14 are not quite as easy to list. But the least common multiple is going to be 70. I did want to show you a little trick I learned years ago for finding the least common multiple of tricky numbers, not like 6 and 8, but bigger numbers like 10 and 14 or even larger. You can list the two numbers side by side like this, and then I put just like a little like L shape next to them just to kind of split this up. And think of a number that both 10 and 14 divide by, which is 2. I put that right here. 10 divided by 2 is 5. I put it below the 10. 14 divided by 2 is 7. I put it below the 14. And I do double check to make sure that these two numbers don't divide by anything besides 1, which they do not. And then I just multiply these three. See how it forms an L for LCM? 2 times 5 times 7 is 70. So it's a really cool trick you can use if you're ever struggling to find the least common multiple. One thing to stress when we go to do our problems in the next video with different denominators. If you don't choose the least common denominator, but you do choose a common denominator, that's okay. You'll just have to simplify at the end. All right, let's look at example 3. Find the least common denominator of 2/3 and 7/10. So we're looking at the denominators 3 and 10, and the least common multiple of 3 and 10 is going to be 30. And again, we can look at our list that we have here. Smallest non-zero number that's a multiple of both is 30. One option you have is just to multiply your denominators, 3 and 10. That will always get you a common denominator. It's just not always the smallest common denominator. It will be, though, if your denominators divide by nothing besides 1. All right, I have two additional examples, 6 and 9. So we've got 5, 6, and 8 nines. I just want to look at the 6 and the 9. The least common multiple of 6 and 9 is 18. Now, if you were thinking 54, that's a common denominator. It's just not the least common denominator. So you can probably think of some other options, but in this case, the least common denominator to use would be 18. And then in example 5, we have 9/40 and 3/10. We're looking for the least common multiple of 10 and 40. And since 10 goes into 40 evenly, you can just use 40 as your least common multiple or least common denominator in this case. That's really helpful anytime your smaller number goes into your bigger number. Just use the bigger number as your least common denominator. All right, so let's try a few. And again, feel free to try these problems on your own. You don't have to watch every little bit of these videos if you're like, I know how to do this, but please, please, please double check to make sure you have all of the solutions correct. That is important. So number 36, I have 3/7 and 5/14. I'm trying to find the least common denominator for those two fractions, which means the least common multiple of 7 and 14. Since 7 goes into 14 evenly, 14 is our least common denominator. And number 37, we've got 9/10 and 3/20. We're looking for the least common multiple of 10 and 20. Since 10 goes into 20 evenly, 20 is our least common denominator. Always think, what can I rewrite both fractions with a denominator of? And if you're thinking 10, well, you don't want to write 3/20 with a denominator of 10 because then you'll end up with decimals. So it's always going to be at least as big as your largest number. 3/4 and 5/8. We're looking for the least common multiple, 4 and 8. Since 4 goes into 8 evenly, 8 is our least common denominator. Number 39, we've got 1/14 and 3/10. Looking for the least common multiple, 14 and 10. If you look back at your examples, you will see the least common denominator because we found the least common multiple, 14 and 10. It is, in fact, 70. Number 40, we've got 7/8 and 5/12. We're finding the least common multiple of 8 and 12. That will be 24. And finally, number 41, this one's a little tricky. We've got 1/9 and 9/15. We're looking for the least common multiple of 9 and 15. So I started thinking of the multiples of 15, which are 15, well, 0, 15, 30, 45, and I know that 45 is also a multiple of 9, so 45 will be my least common denominator here. All right, in the next videos, we're going to be moving on to adding and subtracting fractions that have different denominators, so you're going to need to have this knowledge under your belt before we get there. Thanks for listening.